Hey guys, this is the second video where we can calculate equilibrium concentrations using a simplifying assumption. Now, like I said before, if you ever find yourself going down the route of having to use the quadratic equation to solve for your unknown variables, then you've actually missed an assumption that you can make. First thing I want to point out with this problem is what it is. It's the decomposition of phosgene, COCl2, which is a chemical warfare agent that we now, chemical warfare has been outlawed. All the developed countries say, we will not use this. This is not fair. And phosgene is one of those chemicals that is on the list of what we would not use during war. This substance decomposes to carbon monoxide and chlorine gas, and the Kc for this is 8.3 times 10 to the negative 4. And so one of the things I want to point out is it's 10 to the negative 4. That's pretty small. And you can use the assumption that we're going to talk about if your Kc is small, 10 to the negative 4, or even smaller, 10 to the negative 5, 6, 7. What this means, of course, with a smaller Kc is that decomposition is, in this case, is relatively to a small degree. So there's not a whole lot of carbon monoxide and chlorine gas made, and that this stuff, its concentration doesn't change by a whole lot because K is rather small. Only a small amount of it breaks off. So when we do this, because we're figuring out equilibrium concentrations, right, we need to do a Rice table. So for our reaction, CO, Cl2, CO, and Cl2, RICE. Our initial concentration is, let's see, that says, I hope you can read that, 5.00 moles of the phosgene. And if there's 5 moles, but it's in a 10-liter flask, our initial concentration is actually 0.500 molar. And we don't have any of this, and we don't have any of this yet. Our change is minus x, and plus x. With 1, 1, and 1 in our balanced chemical reactions, we have x, x, and x. Don't forget that if our balanced chemical reaction has coefficients other than 1s, we would take those into account. And so at equilibrium, it's 0.500 minus x, and plus x. When we write out our equilibrium expression, that's equal to the carbon monoxide concentration times the chlorine concentration divided by COCl2. And what we get is x times x over 0.500 minus x, or x squared over 0.500 minus x. And I believe in the problem, yep, we have all of this equal to 8.3 times 10 to the negative 4. Let's look again. Yep, 8.3 times 10 to the negative 4. Now, one thing that we notice here is that this could get a little bit messy with this math here. And we make an assumption. You assume that because Kc is quite small, that 0.500 minus x is about equal to 0.500. The initial concentration of the COCl2 of 0.500 really isn't going to change much, because x is in fact so small because Kc is small. Now there's going to be a way to check whether or not this assumption is relatively valid at the end, but what this will allow us to do is simplify the whole bottom part of this equation. And so this now simplifies to x squared over 0.500 is equal to 8.3 times 10 to the negative 4. So on the AP, if you're in a situation like this and you note that the Kc value is rather small, 10 to the negative 4 or smaller, there's a good chance that you can that you should follow this route, that you should make this assumption. Of course, this wouldn't be true if Kc were not small. If Kc were larger, this assumption right here, that 0.500 minus x is about equal to 0.500, would not be true. But now that we have made this assumption, we can simplify, right? X squared is equal to 8.3 times 10 to the negative 4 times 0.500. And what we get is x is equal to, let's see, about 2.0 times 10 to the negative 2. And the assumption that we make is this less than 5%? Is this molarity less than 5% of this molarity? So we do a quick check. What we do is this assumption valid? So we figure out the percentage that breaks off from the 0.500. And this equals about 4%. So 4% is less than 5%, so it is valid. So 5% is the number, the target number we're looking at. If the amount that comes off is greater, if the concentration is greater than, or 5%, or well, greater than 5%, then the assumption that we just made isn't valid, and that you would have to do a lot more complex math. However, we can do this on the AP, and they will all, basically on the AP, they'll always give you a situation where you can do this. If this is your scenario, you should look to make this assumption. Once we do this, we then realize that this value of x is valid, and we look back up at our equation. So therefore, the carbon monoxide and the chlorine gas, both of which are 2 times 10 to the negative 2 molar, and we say that the COCl2 is equal to 0.500 minus 2 times 10 to the negative 2 equals 0.480 molar. And that's how you solve these types of problems using this assumption. Looking back up at the top, we've solved for part A. Part B asks if we had a starting amount of 0.100 mole. Now you would go through the same process, solving, and I think what we would find is that because this is a smaller amount to start, that we would end up with a larger than 5% value of x for x compared to the original. And that said, I do believe this type of problem would not be on the AP. So we're going to ignore this for now. You would never be put in this scenario where you couldn't make this simplifying assumption. Alright, so that is how you solve for the concentrations of equilibrium species using the assumption that when K is quite small.